Welcome to today's training on Benford's law. Let's start out by looking at the leftmost digit of our sales values listed here. We see that from 15 our leftmost digit is 1, from 42 our leftmost digit is 4, from 137 our leftmost digit is 1, and so forth. Benford's law states that in nature, these sales numbers' leftmost digits aren't uniformly distributed. In the real world, Benford's law states that numbers have a 1 in their leftmost digit roughly 30% of the time, a 2 as their leftmost digit roughly 18% of the time, and a 3 as their leftmost digit 12% of the time, and so forth, following a rather logarithmic pattern. This may come as surprising, but it's actually quite common. So common, in fact, that it is not uncommon for Benford's law to be used to detect accounting fraud among various other forgeries. Let's go ahead and check Benford's law against Tableau's own famous Superstore dataset. After all, this data is computer generated, and it's doubtful that the people who made the data modeled the sales after Benford's law. Let's go ahead and look at what our end result will be. You can see that from the data on this left-hand screen, you'll have a 1 about 30% of the time, a 2 roughly 18% of the time, and so forth. Let's go ahead and get right to it. I'm going to go ahead and use this new data source just to clear any calculations I may have created earlier. And we're going to go ahead and create a leftmost sales digit. So as we saw over here, we see that we have in our data, we have these leftmost digits. Let's go ahead and bring that into our example here. So to do that, we're just going to go to Analysis and create a calculated field. We're just going to go ahead and call this our leftmost sales value. And that's just going to be a left of sales, comma 1. So our left function here takes a string, which is going to be sales, number of characters, 1. Now you'll notice that this calculation is invalid here, and it's saying that left is being called with a float, comma integer. Did you mean a string, comma float? So right now we have sales, which is a float or a number, and a left is a string function, so we're just going to have to convert our sales into a string for this to work. So now our left function is working beautifully. It's identifying our sales as a string. It's taking the leftmost digit there. So let's go ahead and say OK. Let's go ahead and take this leftmost sales value and drop it into the view. We can see we have all the numbers between 1 and 9 available to us. And if we go ahead and take our number of records, drop that right there, we can see the distribution of the number of 1s, the number of 2s, numbers of 3s. We can go ahead and turn on our ABCs here, maybe make this a percent of total by right-clicking on it and changing it to a quick table calculation, percent of total. So now we have a nice illustration of Benford's law. Let's go ahead and see how we can make this even a little bit more interesting. Here we see we have these nice colors, and here we don't. So I'm going to go ahead and look up Benford's law on the internet. Here we have Benford's law, and we can see the equation down here. You can see it's for base 10, which is our general number system. You can change the base for a variety of other ones. So Benford's law states that log base 10 of d plus 1 minus log base 10 of d equals log base 10 of 1 plus 1 over d. So a set of numbers is said to satisfy Benford's law as a leading digit between 1 and 9, inclusive, occurs with probability this. And then here are the numbers that we get for a base 10 system. So let's go ahead and enter this equation, this final equation that we see here, into Tableau. So log base 10, parentheses 1 plus 1 over d. So I'm just going to go shrink this. I'm just going to shrink this a little bit. There we go. And we want to use this equation here. So I'm going to go up to Analysis and create a calculated field. And we're going to shrink this a little bit so we can see that equation. We're just going to go ahead and call this Benford's rule. Okay. And that's just the log. So we're just going to go in here It uses log here. Log of 1 plus 1 over our leftmost sales value. Now you'll notice again this is going to error out. Can't divide an integer by a string value, so we need to convert that back to an integer. Remember, it's a string at this point. So now this is going to be Benford's rule, log of base 10 of 1 plus 1 over int of 1, or 2, or 3, or 4, or 5, or 6, or 7, or 8, or 9. Great. Let's go ahead and say, OK. I'm going to go ahead and make this a little bit bigger. And now we're just going to go ahead and take Benford's rule, place it on the detail shelf. You'll notice that it's going to sum Benford's rule up, but we don't want to sum it. We actually just want a most bare minimum value there, so we're just going to change it to minimum. And now we're going to add it as a reference line by right-clicking on this axis and adding a reference line. And we'll go ahead and choose something like distribution. And maybe we would like it at the 80, 100, and 120 percentages. We're going to go ahead and use Benford's rule. We'll go ahead and fill above, below. Don't want any labels in there, and we'll just use a stoplight color. You'll notice I did this across the whole pane, but we actually want it for each individual cell, each individual bar. So I'm just going to do it per cell here. Now we can see a nice distribution of Benford's rule, and whether things are outside or inside the norm. So maybe if I wanted to see, well, I wonder if someone's committing fraud in one of my departments, I can say, well, is it in one of my categories? I can drop categories there, and now I can see, oh, whoa, office supplies, 35%, that's a 5% difference from Benford's rule, which is 30.1. This is only about 1.7 away. This is only about 1.2 away, but this is 4.9 away percent. So maybe there's an issue here where someone maybe is aware of Benford's rule and is trying to manipulate the numbers. So you can see how people might be cheating your system or falsifying records using Benford's law.